Hello everyone. In this session we will just discuss the instruction formats. So instruction has three fields. First field is the opcode, the second field is the address field, and the third field will be the mode field, which will specify what type of addressing mode it is. So opcode specifies the operation to be performed, whether it is addition, subtraction, move, push, pop, all these are opcode fields. The address can be address of a memory or it can be the address of a processor register. And the mode field which tells the way in which you have to interpret the address field, whether it is a memory or whether it is a register or what calculation you need to access, do the access of data will be given by the mode field. So the number of address fields in the instruction depends on the internal organization of the CPU, and there are different instruction formats. So it can be a single address instruction or three address instruction or two address instruction, or it can be zero address instruction. So based on the number of operands that are specified in an instruction, we can differentiate or categorize into different types of formats. So if it is a single address that can be specified in an instruction, so for example, you have the addx, which is which has only one operand specified. In this case, there is an implicit register called the accumulator where the other operand is available. So the processor will take the operand, one operand from accumulator, and the other operand is given in the value x, adds it, and the result will be available in the accumulator. So for all instructions, the implicit register will be accumulator. Then you have other three address formats where you have add R1, R2, R3. So R2 and R3 are added and the result is stored in the register R1. So you have three explicit operands specified in the instruction itself. Then the third category is the add R1, R2 where only two operands are specified in the instruction. So this tells that you can have one register, the two operands, source operands are available, and one register or one operand will act as both source as well as destination. So in this example where we have add R1, R2, R1 acts both as the source as well as the destination. So R1 will be equal to R1 plus R2. So here move R1, R2 is again an two address instruction where the contents of R2 is moved into R1, and add R1, X where X is a memory and R1 is a register. So R1's content and the memory content X will be added and the result will be stored in R1. Then finally, you have zero address instruction. So for example, in the last add instruction, you can see there are no operands. So there is an implicit location where the operands are available. That location you call it as a stack. So if the processor is a stack organized processor, then we will have zero address instructions. So you can push X, push Y, everything, and then you can just give add. That means the top two contents of the stack will be added and will be stored into the stack. So here is an example of how to evaluate an expression x is equal to a plus b into c plus d with a three address instruction. So a and b are added and the result is stored in R1. C plus d is added and is stored in register R2, and you have multiply x, which is x comma R1 comma R2. R1 and R2 are multiplied and the result is stored in x. And you also have an example for the two address instructions. So if you have two addresses, then one will act both as a source as well as the destination. So what we need to do is you have to bring one operand into a register. So here A, you have to move move it to register R1. Then you can add R1 comma B. So the first part of the sub expression will be available in the register R1. Then same way you have to move C to R2. Then R2 is added with D. So R2 will contain the value C plus D. Now you have to multiply R1 and R2. So multiply an R1 and R2, the result will be available in R1. Now from R1 you need to save it into the memory location X. So you are giving move R1's content into X. So this is how a to address instruction is written for an expression A plus B into C plus D. The same thing you can write it in one address instruction. So load A loads it. One address means the implicit register is accumulator. So one operand is loaded into the accumulator. So it is load A. Then you are adding B. The result is available in the accumulator. Now you have to store it in some temporary location. So you are giving it store T. Same way load C loads it into accumulator. Add D adds C plus D and multiply T. It will multiply it with T and the result will be available in accumulator. Now you have to store the result into X. So store X. Now the same thing you can do it with a single zero address instruction. You have to use a stack. So push A, push B, add. So it adds A and B and stores it into the stack. Push C, push D, add C plus D and pushes into the stack. Now if you multiply, the top two contents will be popped, multiplied and will be stored into the stack. Now you give pop X, the result will be stored into the memory location X. Thank you.